All right, 5-3, more with bisectors. So a term that you're going to need to know is the term concurrent, which is anywhere where three or more lines intersect at one point, and that point is called the point of concurrency. So the concurrency of perpendicular bisectors theorem. So perpendicular bisectors are these right here. So this is a perpendicular bisector because it's perpendicular and it bisects this line from here to here, that side, in half. So bisecting means it cuts it in half. So that's why you can see that each side has got a little mark here that indicates that it's equidistant, so cut in half. All right, so basically, when that happens, then each of these, so this point in the middle here, this is called the point of concurrency, and it is equidistant from each of the 3 points, just like that. And if you were able to draw a circle, so we'll see how good this goes. Yeah, that's not going to go very well. You would be able to use that as the center, and then it should, if it was a perfect circle, which this is not going perfectly well, it would, there we go. Then, so this is the center, and then you could see that it hits each of the 3 vertices. Then there's one called the concurrency of angle bisectors theorem. So that was perpendicular bisectors. So you can see this one is a little bit different because the angles are where it's being bisected. So it's cutting each of these angles. This ray is cutting each angle in half. So this point in the middle, now this one doesn't necessarily have to be inside the triangle. Oh, actually, this one does too, yes. Both of these have to be inside the triangle. And then what's going to happen here with this one is going to be where it will actually hit all 3 sides of the triangle. Like that. So this is the center, and then you can see that, it hits all 3 sides at one point. And so this one is equidistant from the sides. So making a circle. All right. Now the real question is, how do we use these theorems? Well, we can use this theorem to find the distance of a side when we have an angle bisector. All right. So for example, or for these steps, you're going to do these things. So number 1, you're going to set the part of the side split by the bisector as a ratio to the adjacent side. So that means I'm going to take 2 and I'm going to compare it to 4. I'm going to take 3 and I'm going to compare it to really what's going to be x. Where there's a question mark, that's an unknown, so we'll use x. So that means we're going to use a ratio. So ratios are going to be in fraction form for us. 3x is equal to 2 over 4. And then we're going to solve with cross products. So cross products means this. I'm going to put the 2 times the x on one side of the equation and the 3 times the 4 on the other. So on one side here, I'm going to have 2x, and it's going to be equal to 3 times 4. So 3 times 4 is 12. Divide each side by 2 to get rid of this 2, so that is eliminated. So x equals 12 divided by 2 is 6. Okay, next problem, I'm going to do the same thing. I'm going to compare the 4 over here, and I'm going to compare this side to the 9. Well, what is this side? Well, truthfully, this side is 10 minus 4, right? Because the whole distance is 10. Part of it is already identified as 4, so we know that this side is going to be 6. So we have 6 over 9 is equal to 4 over x. We're going to do our cross products. So 6 and x are together, and 4 and 9 are multiplied times one another. So to solve that, that's 36 equals 6x. Divide each side by 6. That gets eliminated. The 6 is on that side, so x is equal to, well, 6 again, actually. All right. And then lastly, we'll step it up and use some algebra, but we're still going to use the same system. So I'm going to compare one part of the side that's been split to its adjacent side, and I'm going to compare that to the other, or use that to compare to the other side. So I'm going to have 6 over 15 on one side, and on the other side I'm going to have negative 12 plus 2x divided by 10. Now this is going to get a little bit tricky, so watch with me here. So I'm going to do my cross products. So on one side it's really simple. I'm going to have 6 times 10. The other side, however, I'm going to have 15 times this whole section up here, the negative 12 plus 2x. Now, don't get too fast in solving for this right side. Just do the left side. So let's do that's 60 equals 15 negative 12 plus 2x. I'm just rewriting it. Now, this is multiplication, 15 times the quantity of negative 12 plus 2x. So I'm going to actually divide by 15 right now. I do that because 60 divided by 15 is 4. And now I don't have to actually go through and multiply 15 times negative 12 and do all that. So pretty simple. Now to get rid of the negative 12, I'm going to add a 12 to each side. So that's going to be 16 on one side and 2x on the other side. And lastly, I'm going to divide by 2 on both sides. That gets eliminated. I have x, and then 16 divided by 2 is 8. So that is how you solve for those problems.